Hello everyone, so welcome to this video tutorial. So hope that you will enjoy this video tutorial. So my topic is all about the other discontinuous distribution. So I am the reporter, I'm Mr. Kim Kirdosipin, and anyways, you can ask questions, just comment below. So let's proceed to our topic. So distribution. The logistic distribution is a continuous probability density function that is symmetric and unimodal. It is similar in appearance to the normal distribution, and in practical applications, the two distributions cannot be distinguished from one another, so they are quite similar. So let's see their graph is the and this is the graph of the normal distribution. So as you can observe, the two graphs are quite similar. So let's proceed to the definition of the logistic distribution. So anyways, do you ever ask yourselves what is a logistic distribution? So okay, the definition goes like this. So this distribution is characterized by two main parameters, the location mu, and the scale sigma. Again, what is the scale? The scale sigma. So the probability density function in f of x is equal to 1 over sigma times e to the power of negative quantity x minus mu over sigma all over 1 plus e to the power of negative x minus mu over sigma quantity squared. So again, what is logistic distribution? So the cumulative distribution of the logistic is the famous S-shaped curve on which logistic regression is based. So it is f of x is equal to 1 all over 1 plus e to the power of negative quantity x minus mu over sigma. Alpha is less than infinity and also greater than negative infinity, and beta is greater than 0. So the mean of the logistic distribution is given by alpha, and the variance given by beta squared pi squared all over. So we note that f of a alpha minus d with the parameter of alpha and beta is equal to 1 minus f of a alpha plus d with a parameter of alpha and beta, and so the density of the logistic is similar about alpha. This distribution has been used to model tolerance level of buoyancy problems. So let's proceed to the Pareto distribution. So are you excited to know what is Pareto distribution? Are you excited? So if you're excited, please bear with me. So the Pareto distribution is skewed distribution with heavy or slowly decaying tails. Much of the data is in the tail, so it merely focuses on the tail. So what is Pareto distribution? The Pareto distribution is given density function formed by f of x with a parameter of x sub 0 and theta sub x is equal to theta over x sub 0 times the quantity of x sub 0 over x to the power of theta plus 1, evaluated from x sub 0 to infinity. So where theta is greater than 0 and x sub 0 is greater than 0, so the mean and the variance respectively of Pareto distribution are given by theta x sub 0 over theta minus 1 for theta is greater than 1, and the variance, which is theta x squared sub 0 all over theta minus 2 minus the quantity of theta x sub 0 all over theta minus 1 quantity squared for theta is greater than 2. So this distribution found application in modeling problems involving distributions in incomes when incomes exceed a certain limit of x sub 0. So the algebraic moments are given by expectation of x to the power of n is equal to the integral of n x to the power of n f of x starts from k to infinity is equal to the integral of x to the power of n alpha k to the power of alpha all over x to the power of alpha plus 1 evaluated from k to infinity is equal to the quantity of negative alpha times k to the power of alpha all over x to the power of alpha minus n plus 1 quantity evaluated from k to infinity is equal to alpha times k to the power of alpha all over alpha minus n, which is defined for a is greater than n. So as you can see, this one is quite similar to the expectations of x, which is alpha alpha times k to the power of 2 all over alpha minus 2 times the quantity of alpha minus 1 than 2. So now let's proceed to the Gumbel distribution. So, okay, what is Gumbel distribution? Do you have any idea if what is Gumbel distribution? So if none, so let's proceed to the definition. So the Gumbel distribution, generalized extreme value distribution type 1, is used to model the distribution of the maximum or the minimum of a number of a sample various distributions. Anyways, Gumbel distribution is really important in predicting earthquakes or measuring the floods. So this distribution might be used to represent the distribution of a maximum level of a river in a particular year if there was a list of maximum values for the past 10 years. It is useful in predicting a chance that an extreme earthquake, flood, or other natural disaster will occur. So this is very useful. So let's proceed to the definition. So this is the example of the graph of the Gumbel. And then the cumulative distribution function f of x with the parameter of alpha and beta is equal to e to the power of negative e to the power of negative x minus alpha over beta. Okay, so where alpha is less than positive infinity, where alpha is greater than negative infinity, and beta is greater than 0, is called a Gumbel distribution. It appears as a limiting distribution in the theory of extreme value statistics. So let's proceed to the Pearsonian system of distribution. So, okay, since we are already done with the logistic distribution, Pareto distribution, and Gumbel distribution. So let's proceed to the Pearsonian system of distribution. So in statistics, a family of continuous distribution functions first published by British statistician Carl Pearson in 1895. In particular, Pearson showed that many probability density functions satisfy a differential equation of the form in simplified notation. So, consider a density function f of x sub x which satisfies the differential equation. So, 1 over f of x sub x times the differential of x sub x over d sub x is equal to x plus a all over b sub 0 plus b sub 1 of x plus b sub 2 multiplied by x squared. For constants a, b sub 0, b1, and b2, such density is said to belong to the Pearsonian system of density functions. Many of the probability density functions that we have considered are special cases of the Pearsonian system. For example, if f of x sub x is equal to lambda to the power of r multiplied by x to the power of r minus 1 multiplied by e to the power of negative lambda x all over lambda times r evaluated from 0 to infinity. So we get negative lambda plus r minus 1 over x is equal to x minus quantity of r minus 1 all over lambda all over negative x over lambda for x is greater than 0. So gamma distribution is a member of Pearsonian system with alpha is equal to negative quantity of r minus 1 all over lambda. B sub 1 is equal to negative 1 over lambda, and B sub 0 is equal to B sub 2 is equals to 0. So that ends my report. So Thank you for listening. Hope you'll enjoy the topic. And if you have any questions, just comment below. And always remember that in mathematics, you must do your job and duty. That would be all. Goodbye and God bless on your final exams.